but I have taken this as separate unit as capacitance. According to me, in physics, there are at this particular moment of a class 12 physics, there is two significance of capacitance. The first thing, it is a continuation of potential, so yeah, you will understand. So the first body that I am having is known as spherical capacitor. This is known as spherical capacitor. Okay, and let me inform you that this is known as useless capacitor. This is, in another term, it is known as useless capacitor. After explaining a while about this, you have to decide that why it is called a useless capacitor. If I am having a sphere, the sphere is having the charge q and the radius r. Okay, so charge q will be accumulated on the outer surface of this. Okay, the radius is r here. What is the electric field inside? The electric field inside this is 0. Okay, what is being happening here? Right now I found that the value of the capacitor is simply 4 pi epsilon naught r. Right, I got it. Now this conductor will keep on radiating the electric field in the outer direction, just like a point positive charges do. Okay, so this is the direction of the electric field that is radiating outward. After giving this much explanation, can you help me tackle that why this is known as a useless capacitor? Definitely, I told you that capacitor is containing the electrostatic energy in the form of electric field, and this spherical capacitor is radiating electric field outside. If this is radiating electric field outside, it is radiating all the potential energy that it is capable to hold. Since it is radiating all the energy it is capable to hold, what I will understand from here, that this is a useless capacitor. Okay, got it. Here also, if it is said now that you need to be optimism. So even if I use this as optimism, I cannot say that the electric field is going away. Okay, we can say that the electrostatic energy here, the electrostatic energy is stored. It is stored from surface of the charge, from the surface of the sphere to infinity. Okay, basically the electric field is bonded here between the surface and the infinity. Therefore, yeah, this is a highly large capacitor. You can say that this is a highly large capacitor. Why? Because the electric field is bonded between the surface and the infinity. Okay, but still it is useless because you can understand why. Okay, got it, guys? Okay, what happens if I just simply take a planar capacitor? What does a planar capacitor means? So planar capacitance means I am having a plane sheet. This is my plane sheet. Okay, just a minute. This is my plane sheet. The plane sheet is carrying the charge q. Okay, so what is happening here? It is the charge q and the area is mentioned as a. At a certain distance from this, the value of the electric field is simply sigma by epsilon. This is the direction of the electric field from here. So this is also useless. Exactly, this is also useless. Why this is useless? Because here also the electrostatic potential energy is between the surface of this, between the surface and the infinity. So if it is stored between the surface and infinity, I will be able to say that yeah, this is also a useless capacitor. But if I take a parallel plate here, okay, a parallel plate capacitor. So what is parallel plate capacitor? I am having two plates that are placed parallel to each other. So if I say that I am having two plates which are parallel to each other, so let us say that this is one plate and this is another plate. Okay, both of them are carrying equal charges like this. Okay, so I will say that here, what is the value of electric field in between? The value of electric field in between is 0, because both of them will exert electric field opposite to one another, that will cancel each other. So the net electric field is inside 0. And what is the electric field outside? Electric field outside is E. This is more useless than the previous one. In previous one, you were having the energy stored here between surface and the infinity. Here the value of the energy, here also it is useless, as the electrostatic potential energy is not in between, but between the surface and infinity. Okay, so yeah, repeating it again, that here the electrostatic potential energy is not in between of the parallel plate, but yeah, it is between the surface and the infinity. So still it is useless for me. What is much better for me is a parallel plate capacitor of equal and opposite charges. Okay, if instead of this previous thing that I have done, I take parallel plates here, okay, that carry the charge q, okay, let's say positive q and a negative q, you will find here that the electric field inside is directed to this way. What about the electric field outside? You will find that there is no electric field outside. Why no electric field outside? Because whatever electric field will be created, that will be cancelled by the other one. So I can say that whole electric field is stored in between. Okay, electric field outside is 0, electric field inside is basically equal to E, and all electric field is inside is between the plates of the capacitor. Therefore this is the best capacitor that I have got to know right now. Okay, is this clear everyone, that how I found this? Okay, since all the electric field energy, all the electric fields are between the parallel plate, I can say that the entire energy is present between the two plates. So this is the best way to store energy. Whenever I wish, I can use that, right? Okay, so this sounds very good. In the similar way, I can convert this spherical capacitor also in a good capacitor. How can I convert this into a good capacitor? Okay, let me keep it a bit aside. Just a minute. Okay, Even you can convert this as a good capacitor. How? You can simply take a positive, you can simply take one sphere here and another sphere here, both are overlapping. Okay, let us say that this radius is R, this radius is capital R. So you will find that if I place positive charge inside, okay, automatically it will induce negative charge inside. Okay, it will accumulate negative charge inside. So I can say that the entire electric field is present in between of two. The entire electric field is present in between the two plates of the sphere, two surfaces of the sphere. Therefore, this is also a good capacitor. This is also a good capacitor. Why? It is capable to store the energy between the plates. Okay. In the similar way, if I am having a cylindrical capacitor, the story is gonna be same. Cylindrical capacitor, the story is gonna be same. How it is gonna be same? So this is one, okay, and this is another one here. Okay. If I say that, just a minute. Okay, if I say that the inner one is charged positively, you'll find that the inner one is charged positively. So the outer one will be charged negatively all around. The outer one will be charged negatively all around. Got it? So what will happen here? The entire electric field is present between the two ends of the between the two surfaces of the capacitor, between the two surfaces of the cylinder. So this is also a good capacitor. This is also a good capacitor. What if it is present solely? So if it is present solely, it is present alone, then definitely this will be a bad capacitor. Got it? I hope this is clear. Okay, perfect. So yeah, this was something which we are required to know. Okay, so let me let me just repeat it again. What is a capacitor? Okay, so capacitor is a device, okay, which is used to store the electrostatic energy, okay, by storing the charge. Because if there is charge, there will be electric field, and the electrostatic potential energy will be present in the electric field that is stored here. Okay, so if I want to measure the capability of the capacitance, I will have to introduce a term that is known as capacitance, and this capacitance is basically the measure of the energy stored. This is basically the measure of capability or capacity of a capacitor. Okay, it is measured in terms of farad, but farad is not useful to us a lot. Therefore, it is measured in. Therefore, we use microfarad in our questions. Okay, this is the scalar quantity of the capacitance. Now, the value of the capacitance is equal to C by the value of the capacitance C, okay, which is equal to Q by V. But you will find it very strange that the capacitance does not depend upon the charge and the potential. Okay, instead, because if you will increase the charge, the potential will automatically increase and it will adjust the previous one. Okay, so instead of this, you will find that the capacitance depend upon the size, okay, and depend upon the medium that it holds. And how I got the proof of this? So I got the proof using a spherical capacitor. For a spherical capacitor, I want the capacitance to be 4 pi epsilon naught R, which means that the capacitance is dependent upon the radius and the medium itself, not on the charges. Okay, this was something I got to know. Then I found that if I'm having a single spherical capacitor, that is useless because it will radiate all the electric field, and the electric field is present between the surface and the infinity. So now the energy is not confined, therefore it is not useful to us. But if I'm having an external sphere which is enclosing it with a negative charge, okay, with the opposite charge, you'll find that the energy is stored here, and yeah, this is something useful. If I'm having a plain capacitor, that is not useful to you because it will radiate electric field again present between the surface and the infinity, so no use to us. So you can use a parallel plate. But if you are using a parallel plate, that too with the same polarity of the charges, you will find that inside there is no field present, but all the field are present outside, again between the surface and the infinity, which is not useful to us. Okay, and definitely this will be of no use. So if I take two parallel plates, okay, of opposite charges to each other, the electric field will be confined between them, and this is the good capacitor that we can have. Okay, and even we use for our question, we will use the parallel plate capacitors only. Okay, there is also one alternative that you can take a cylindrical capacitor where two cylinders enclosing one another will have opposite charges, so the electric field remains confined there. Got it? So that's all for today. We'll be meeting in the next lecture. Please at least maintain the pace in capacitance because this will form the ground for your next chapter of current electricity. Okay guys, so take care, bye bye. We'll be meeting in the next lecture.
The problem is not effort, it's lack of personal attention. With one-to-one mentoring, every doubt is addressed, every concept is applied, and real improvement begins.